Welcome to Python Basics, Strings and String Methods. I'm Christopher Bailey, and I'll be taking you through this course. Python programmers deal with text daily, whether it's displaying text in a web page or within a graphical user interface, or even accepting input a user has typed into your application. There are even entire segments of data science that deal with extracting information from text, such as sentiment analysis. Collections of text in Python are called strings. And there are special functions called string methods used to manipulate strings, like changing a string from upper to lower case, or removing white space, or replacing portions of the string with different text. In this course, you'll learn how to do some of that manipulation of strings using string methods. You'll work with user input. You'll learn how to deal with strings of numbers and turning numbers into strings, how to format strings for printing. And along the way, you'll learn about f-strings, multi-line strings, how to do string indexing and slicing, what is string immutability, and how to discover additional methods using idle yourself. Let me quickly take you through the table of contents. There's this overview that you're watching currently. Then you'll define what is a string. Next up is concatenation, indexing, and slicing of strings. And then how to do some of that manipulation of strings using methods. You'll learn how to interact with user input, and then working with strings and numbers, how to streamline your prints, and then how to find strings within strings. Then you'll wrap up with a summary and a collection of additional resources for you to continue your learning. All right, it's time to dig into what is a string. In this lesson, you'll dive into what is a string. Previously, you might have created some programs in Python. And to start with, you've probably created the string hello world and printed it out inside of an interactive session. In this lesson, you'll get a deeper look into exactly what strings are and the various ways you can create them in Python. Strings are one of the fundamental Python data types. The term data type refers to what kind of data a value represents. And in the case of strings, they represent text. There are several other data types built into Python, such as numeric ones like integers and floating point numbers, booleans, and sequence types like a list or a tuple, which a string is actually part of. You'll learn more about that later. What does it mean to be a fundamental data type? It means that it can't be broken up into smaller values of a different type. Those are actually called compound data types and are commonly known as data structures. Future Python Basics courses will dig into data structures. The string data type has a special abbreviated name in Python, str. To see it, you can use the built-in type function to show the data type of a given value. Let's check that out in an interactive window. Open up idle, and it should automatically create an interactive window. At the triple prompt, type out the word type. You'll see that it identifies itself as a function, and it's expecting an object. In this case, we're going to put a string inside of it. If you type with quotation marks, hello world, it will show you the type. The output is class str and indicates the value hello world is an instance of the string data type. And basically, hello world is a string. For now, you can think of the word class as a synonym for data type, although it refers to something more specific, and you'll get further into that in your Python basics journey. Type also works for values that you've assigned to a variable. So create a variable named phrase, and then use the assignment operator, the equal sign, and type a phrase into it. So maybe we just put hello this time. You can use type and place phrase as an object inside of it, and it knows that phrase, the variable, is assigned to the string hello. And it's a type of string. Strings have three important properties. They contain individual letters or symbols called characters. They have a length defined as the number of characters that are contained within the string. And those characters within a string appear in a sequence. Each character has a numbered position. It's called an index. Here's two examples of strings. As you can see, you can use single quotes or double quotes at the beginning and the end, as long as the same type is used at the beginning and the end of the string. So in the case of string 1, you're using single quotes around hello world. In string 2, it's using the double quotes around the numbers 1, 2, 3, 4. Text surrounded by quotation marks like this create a string literal. The name literal indicates that a string is literally typed into your code. String literals are written in a couple different ways. Again, you can use the single quotes, which allows you to embed double quotes within it, or you can use double quotes on the outsides at the beginning and the end, and that would allow single quotes on the inside. Triple quotes is the third way you could possibly go, and they provided some additional value you'll learn about shortly. Either 3 single quotes or 3 double quotes at the beginning and the end. Strings can contain any valid Unicode character. So Unicode characters go beyond the simple letters of the alphabet that you've seen and include the symbols like an apostrophe or the number symbol and other punctuation marks. And they include numbers, plus symbols that are involved in other languages that you might have seen, plus emoji. All of these are valid strings. So when creating strings, such as the ones in the example, you can use single quotation marks, or you can use double quotation marks. And again, you could put all types of different characters in them. If you were to try to assign with only a single quotation mark, but then use a different type at the end, it will let you know that you've not created the string properly. It's not a proper string literal because it doesn't start and end with the same type. The quotation marks surrounding the string are called delimiters. They tell Python where a string begins and where it ends. When one type of quotes is used as a delimiter, the other can be used inside of the string. So that allows you to do something like an apostrophe. That's a valid string. As again, the beginning and the end are the double quotes. Or let's say you had a phrase in that case, you could use single quotes as delimiters, and inside here, you could have its own quotation. That's valid too. So what isn't valid is to do something like, and you can see it already kind of behaving differently inside of here. It thinks that the delimiters are saying this is the string and then wondering what this syntax is after that. So this is invalid. If you need to include a quotation mark that matches the delimiter inside the type, you can do something called escaping, and that's done with a backslash. So you could do something like this. Let's redo string 6 and then put a backslash in, and that allows you to include a quotation mark inside of your string, or in this case, a full quote. That's one way to accomplish it. If you were to print out string 6, you'll see it print out with the quotation marks inside of it. When you're working on a project of your own, it's a good idea to use only single quotes or only double quotes to delimit your strings. It's sort of a consistency thing. It helps to make your code easier to read and understand. The number of characters contained in a string, including spaces, is called its length. To determine the length of a string, you can use the built-in length function, which is abbreviated just len or len. It's going to return the number of characters contained in a string, including spaces. So try out the built-in length function. Type len, and then you can put, again, a string literal right inside of it. It returns the number of characters. It also works if you've assigned the string to a variable. And even a phrase that has other characters than just the alphabet, it will count the spaces and the punctuation as separate characters. So in this case, 12. What if you have a really long string? In a previous Python Basics course, you might have learned about PEP8. PEP8 is a style guide for Python. It recommends that each line of Python code, meaning the whole line across that you're typing, contain no more than 79 characters, including spaces. Otherwise, it gets a little hard to contain within the screen. So what if you are, say, typing in an entire paragraph or something longer? There's two methods that you can use to break a string across multiple lines. One method is to add a backslash at the end of all but the last line. So right around the 79th character, you could add that slash. And the other is to use the technique I mentioned before, which is to use triple quotes as delimiters, either the double quotes or the single quotes, 3 at the beginning and 3 at the end. Let me have you try that out in the interactive window. Again, there are two ways to work with multi-line strings. Let's take this paragraph from a book. So putting a backslash at the end of each of the lines allows you to have a string literal that's multi-line. Oh, sorry for the typo at the beginning of it. When you print that multi-line string that's broken up by backslashes, the output is displayed on a single line. So let's say it wasn't quite as big as that, but you had, and you print out the long string, you'll see it connect the whole thing together. The other way that you can create a very long thing, such as a paragraph, is to put it inside of triple quotes. And that will work also. I print out that paragraph. You can see it as the whole thing again. It will preserve the white space also. Let's say you created a long string inside of that print statement. In this case, I've added a few types of white space. And you can see that it preserves that inside there, the tabs and spaces that were added. You'll learn also about how the triple quotations can be used for something called a docstring later in your Python Basics journey. Okay, here's a couple exercises for you to practice what you've learned. Try printing a string that uses double quotation marks inside the string. Then print a string that uses an apostrophe instead of the string. Try printing a string that spans multiple lines with white space preserved. And then print out a string that is coded on multiple lines but gets printed on a single line. Next up, you'll learn about concatenation, indexing, and slicing of strings. In the previous lesson, you learned all about creating strings and writing out string literals. In this lesson, you're going to learn about concatenation, indexing, and slicing. 3 basic string operations. Concatenation joins 2 strings together. Indexing gets a single character from a string. And slicing gets several characters from a string at once. Let's start with concatenation. To combine or concatenate strings, you use the plus operator. You're adding one string to another, and that concatenates them. In this example, string 1, abra, and string 2, cadabra, are tied together or concatenated into magic string by assigning magic string to string 1 plus string 2. Let's try out some examples in the interactive window. Okay, here in the interactive window, create the 2 strings by assigning abra to one and cadabra to the other, and then create a third variable, magic string, and say string 1 plus string 2. That will concatenate them together into abracadabra. Great. Let's say it's something with names. Say you had a first name of Arthur and a last name of Dent, and you wanted to create a full name. That full name, though, needs a space in the middle of it. Well, you can do that through concatenation also. You would add the first name to a string that has a single space in it, and then also concatenate that with last name. So here we're adding first name, space, and last name. That should create the full name Arthur Dent. Now, I'm going to have you look at indexing. Each character in a string has a numbered position. It's called an index. Individual characters can be accessed by using the index. You place the index number inside of a pair of square brackets after the string. Something like this. This would be index 3 and return that character. What may seem a little different is the index count starts with 0. Most programming languages do this, and it is really common to have what's called an off by 1 error, because the thought in your head might be, oh, the counting should start with 1, whereas most often it actually starts with 0. In the case of my string with index 3, that would be the 4th position. Let me show you what this looks like. Let's say you had the string apple pie with a space in between. That string is made up of 9 characters. The indexes start from 0 and go up to 8. So to access the first character, you would use index 0. Let's say you wanted the 5th character. Well, that would be index 4, and so forth. Let's try this out in the interactive window. If you were to use an index of 1, that won't return the first character. It returns the second. The first character, again, because everything is a 0 index, you'd have to use 0. And this whole string is 9 characters, so to grab the last one, it would be 8. To get the space in the middle, it would be 5. If you try to index beyond the range, let's say you use 9, it will tell you that. It will say the string index is out of range, an index error. Strings also have negative indices. The last character in a string has an index of -1. So in the case of apple pie, that would be the E of apple pie. To grab the second to last character, you would enter in -2, and so on. Just like with positive indices, Python raises an index error if you try to access a negative index less than the index of the first character of the string. In this case, -9. If you go lower than that, say something like -10. Negative indices may not seem useful at first, but sometimes they're a better choice than a positive index. Let me have you check that out in the interactive window. So for negative indices, such as the last character in the string, you can start with -1. And to get that first character, that would be -9. What if you go beyond? Again, you get the out of range. This may not seem useful at first, but we'll come up with some handy things for using negative indices here in a second. One way that you could try to access the last character of a string might be to use the length function. You might have some user input as a string. Let's just say somebody had typed hello world into your system and you wanted to grab that D or that last character. You could say, okay, well, the final index is equal to the length of user input. So find the length of the string and then subtract 1 from it. Give me that value. So that, in this case, for final index, that's 10. Okay, so the last character would be user input final index. Again, you could see that this might be much easier to do with just having -1. It's going to take a lot less typing. What if you had a string like you did before of apple pie, and you wanted to return a string that was just the flavor of the pie, just the word apple? Well, this is one way you could do it. But you can see this might be a bit of a pain. We got there, but that's a lot of indexing and concatenation. That's where slicing comes in. You can extract a portion of a string, called a substring, by inserting a colon in between 2 index numbers set inside the square brackets, like this. So in this case, let's say you wanted to return just the flavor of the pie. You could put dessert 0:5, and that will capture just the word apple. A slice starts with the character at the first index and goes up to, but does not include the character at the second index. So in the case of x:y, it starts at the character at index x and goes right up to, but does not include the index at y. In fact, it kind of behaves a little bit more like boundaries around the characters. So let's say we had a fig pie. You can see the boundaries starting there, where if you wanted to capture the flavor of that pie, a fig, you would have 0 up to 3. So for fig pie, the slice of 0,3 returns the string fig, and the slice 3,7 would return the string of a space in the word pie. So let's make a new dessert, a fig pie. So again, if you wanted to return just the flavor of the new dessert, you could go from index 0 up to index 3, and that would return the slice of just fig. If you went from index 3 up to index 7, that would return space and pie. An interesting thing happens if you go over the number. Let's say you went to 3:9. Even though that's beyond that, it's okay. It doesn't create the same kind of error that you got before, where if you went over the index, it told you that it was out of range. It's important to note that, unlike with string indexing, Python won't raise an index error when you try to slice between boundaries that fall outside the beginning or the ending of a string. So even if you went and tried to start at an index beyond that, let's say you went from 9 to 12, it simply returns what's known as an empty string. An empty string, again, a string that has no characters in it, it's still a string. It just doesn't have any characters in it. It's different from one that has a space in it. Yeah, you can see the one space. Or let's say you had like several spaces in there. The spaces still count. Negative slicing works by the same rules. Again, a slice starts at x and includes that character and goes up to, but does not include the character at index y. So in the case of fig pie, -7 up to -4 would capture that first word. Now there's some interesting things that you can do. Like you can see here, how would you capture all of that string of fig pie? Well, there's a couple ways around it. For negative indexing, let's say you started at -7, which would be all the way at the very first boundary, and you went up to -4, that would return again just fig, the slice of fig. Now you might be thinking, well, how do you go all the way up to the end? Would you go from -7 to 0? Because -1 is going to get up to the I of pi, but not include the E. So would you use 0? Well, no, that returns an empty string. And the reason for that is, if you might remember, 0 is already used as an index. 0 is the first character. So there is a way around this. It's to omit the second index. And that means to actually go to the end of the string. So there's 3 different ways that you can omit an index. If you omit the first index, it will start with the very first character of the string from the beginning of it and work normally going up to, but not including the second index number. Doing a slice of :5 will return just apple. If you omit the index after the colon, it's going to end with the last character. So you can see here, dessert 6: would grab just the word pie. If you omit both indexes, that returns the whole string. And you can see that in the bottom example. So that's an option, is that you can omit the indexes to get either the beginning of the string or the end of the string, or in the case of removing both indices, you return the whole string. Okay, I'm going to try a couple of these out in the interactive window, working again with new dessert. If you go from 0 and put a colon, it will capture all the way to the end. If you wanted just the word pi, you could start at index 4 and add the colon, and that would grab just that last word. If you omit the first, again, it will start from the beginning. So if I went from colon 4, that would return fig space. Actually, I just wanted the word fig, so that would be colon 3. And then the last technique that you learned was that if you have just a colon, that will return the whole string. So to wrap this lesson up, one last thing that you need to know is that strings are immutable, which means that you can't change them once they've been created. Let's say you assigned boil to the variable word, and then you went in and tried to change the character that's at index 0, which is the first letter, and you're like, okay, let's reassign the first letter to F. You'll see a type error. String object does not support item assignment. You can't reassign a letter inside there. So to alter a string, you actually have to create a new one, and that can be done through reassignment. This will actually create a new string object. So one way to accomplish what we were trying to do a moment ago, I want to include the last 3 letters of word. In this case, it would be OIL to change word from boil to foil and concatenate that to the letter F. But what's unique here is you're reassigning word. So that's creating a whole new object. In this case, removing the previous one. You have to actually do it through a reassignment statement. It's time for you to practice what you've learned this lesson. Here are a few review exercises to try. Create a string and print its length using the built-in len function. Try creating a couple strings and concatenate them and then print the resulting string. Create 2 strings, use concatenation to add a space in between them and print out the result. Print the string zing by using slice notation to specify the correct range of characters in the string bazinga. Next up, it's time to start manipulating strings with methods.